Okay, welcome back to my video series on programming in ARM assembly. And in this particular video series, I'm trying to create a general purpose function that will serve as a random number generator. Let's get back into the code. So when I left off in the last part, I was a bit rushed there at the end in order to fit the video within the time that I like to allocate. And there's just a little bit of a glitch there. It looks like in the random file I probably have a typo or something. So let's pick up where we left off and see if we can figure that out. So I'm not seeing anything that's jumping out at me. So let me quit out of here. And it looks like the error is in, actually it looks like the error might be in the main file on line 9. I'm not sure. Let me check that. No, I don't think that's it. So what I'm going to do is I'm going to assemble the random.s file by itself. That way I can see more clearly. Actually, I think it's telling me it's on line 33. So let me look on line 33 and maybe that will jump out at me. SVC call. Oh, for some reason I put SVC only here. I should have put SVC call. So I'm pretty sure that was all that was. I just was saying one thing and typing something else apparently. So let me clear the screen. Let me make clean and let me remake. Okay, yeah, that's all that was. So in fact, since that's all that was, I'm going to go ahead and fix just that little glitch there. So what I do is at the end of each recording, I create a subdirectory and I put all the files into that subdirectory from that video. But since that was such a really simple fix, I'm going to go ahead and just fix that. All right, anyway, let's get back into our random.s file. So after opening a file, one thing, the error code essentially that we get back after reading the file is to the file descriptor, the FD. So we will want to do some error handling, but I'll move to that later. But for now, we're just going to assume that the file opened okay, and we're going to save. We're going to store. I like that word better actually. So I'm going to say store the file descriptor. So we're going to come down here, we're going to load into register 1 the memory address for where that file descriptor is located. And then we're going to store into register 1 the value that we got back from register 0. So take register 0 and store it into R1. So when we did this service call up here, we will have received an error code essentially from that open command. And if it was a negative number, then that's a problem, and we'll check for that later. But if it was a positive number, then that will be the file descriptor that we need. So we're going to store that. And then the next thing I want to do is to read the file. So I want to read information out of the /dev/random. So we need to load into register 1 the memory address of our buffer space. And then I want to move into register 2 the size of space that I've defined, and I've defined that already in buff size. So this is where I'm saying read 4 bytes essentially. And then after that, we want to move into register 7 the immediate value 3, which is our read command. And we haven't defined that yet, so I'll do that in a moment. And then in order to make that happen, of course, we have to do a service call. So we'll do our service call. So let's come up here and define what we mean by read. So when the assembler sees the word read, what we really mean is the number 3. Okay, so at this point, we should have our 32 bits or our 4 bytes read, and they should be sitting there in that buffer space. So now let's go ahead and close the file. So let's load into register 0 let me think about this. I might not actually have to do it in this order, because what I'm saying here is load into register 0 the memory address of the file descriptor, but I think we already have that. No, we don't. No, we've already overwritten it. Okay, so we do need to do this. So we're going to load into register 0 the memory address of the file descriptor, and then we're going to load into register 0 the actual value of that file descriptor. So remember, this is just an integer, so it's a number like 1, 2, 3, 4, 5. So we're saying load into register 0 the memory address of wherever that file descriptor was stored, and then load into register 0 the actual number, so 1, 2, 3, 4, 5. And then once we've done that, we can move into register 7 the immediate value 6, which tells the underlying kernel to close out that file. And then we can do the service call to actually make that happen. All right, we don't know what we mean by close yet, so let's come up here and define that. So when we're talking about close, what we really mean is the number 6. All right, so that's everything that we need in order to open the file, store the file descriptor, read from the file, and then close the file. So this would be a pretty good place to check things out and do some tests. But before we can call into this rand function, we want to remember that in order to keep this general purpose, we want to make sure that when we call this function, we're not messing up anything that people potentially have done in the previous function that was calling us. So we want to push onto the stack all the registers that we're messing with. And right now we're doing 0, 1, 2, and 7. But for now, and because I know we're going to work with even more registers, I'm going to say push registers R0 through R7 onto the stack, plus the link register, which is important because the link register helps us keep track of the memory location of where we came from. And then when we get down here to this exit section, we're going to pop off the stack registers R0 through R7 plus the link register. And then we're going to do a branch exchange back to the link register, which contains the memory address of where we came from. And actually, now that I think about it, there's a little bit of a problem, not a problem, but I actually don't want to return, I actually don't want to pop R0 and R1 off the stack, because if we remember, our statement at the top here was that this, when this returns, R0 will contain the error code if there was one, and R1 will contain the random number. So we don't want to save register 0 and 1, because what would happen if we did that, as soon as we popped those back off the stack, we would lose our random number and we would lose our error code. So what we really want to do is push R2 through R7 onto the stack, and then pop R2 through R7 off the stack. Okay, so let's write that out. Let's quit. Let's edit our main file, which is just going to be our driver code. And all I'm interested in for now is just, can I do a branch and link to the rand function and come back? I just want to make sure that I can do that and that I'm not going to get a seg fault, or I'm not going to get stuck in an infinite loop or anything like that. So let's make our code. Okay, there's no errors. So let's clear out. Let's just run the main. Okay, so currently we're able to call into that function, and presumably it's opening the file, reading data, closing it back out, then returning back to main, and then, you know, we're just kind of falling through the exit condition. All right, so let's go back into the random.s file, and now let's think about what we want to do in order to, you know, the way I'm wording this here is constrain the value that we're reading, because remember, we're reading up to a 32, we're reading a 32-bit number from /dev/u random, and chances are we only want a small segment of that number space. That actually reminds me of one more thing. I need to go back into main.s, and before we call rand, we were supposed to move into register 0 some kind of minimum value called min rand, and we were supposed to move into register 1 some kind of maximum value called max rand. So let's go ahead and get that defined here in our driver code, just so that we're not forgetting about it. So we'll come up here under the .global section, and we'll create an equality, and we'll say that when we're talking about min rand, what we're really talking about is the number 1, and when we're talking about max rand, what we're really talking about is the number 100, and we'll play with those values once we get this all worked out. But I just want to make sure I get that done so that I don't forget about it. Okay, so let's go back into random. And down here in the section, by the time we get here, we will have our random number that was read from /dev/urandom, and we need to do something with it. So let me go back to this document and show you what I have in mind. So let me zoom way in on this to make it nice and easy to read. So here we have our ASCII table, which we probably don't need to refer to. So essentially what I want to do is I want to do a modulus function or a modulo function. I always get confused on modulo and modulus, but in short, I just want to find the remainder of a number. So let's just say, for the sake of simplicity, that the number that we get back from the random number generator is this number here. And there's a good chance it'll typically be much higher than that because we are talking about a 32-bit number, but it is possible that we'll get a number like that. And then we have min_rand and we have max_rand as defined. So one thing I need to do is determine what I'm calling a range. So what is the range between 1 and 100? Well, the range is simply max_rand minus min_rand plus 1, and the reason for the plus 1 is because if I say that I want a number between 1 and 100 and I want to include the number 1 and I want to include the number 100, that's why I need to do the plus 1, because otherwise 100 minus 1 is 99, and then I would actually either be generating a number between 1 and 99 or I should, between 1 and 99 or between like 2 and 100. So that's the reason for the plus 1. And then here you can see I'm just taking 100 minus 1 plus 1 to get my 100. So now we actually get into the steps of generating a remainder. As far as I know, there's no modulo or modulus function in ARM assembly. If there is, let me know. It can save me a little bit of trouble. But it's very easy to make one just using division, multiplication, subtraction, addition, that kind of thing. So once we have our random number that was given to us by dev_random, we've figured out the range, very simple. So I want to get what I'm calling, what is the quotient, where I take that random number of 7239 and I divide by the range, and then that's going to give me a number, a whole number. And of course, this would really be 72.39, but when we're only dealing with integers, if you have an integer divided by another integer, you're given an integer. In other words, it chops off the decimal values. So we're given a number 72. So then I want to figure out what I'm calling the product, which is to take the quotient, which is this number, multiply it by the range, which is that number, which is 72 times 100, and that gives me 7200. And then to figure out the remainder, all I have to do is simply take the original random number, what I got up here, subtract off the product that I just calculated here, and that gives me the remainder. And this is the number that I'm saying that we really want in order to generate a random number within this range. And you'll find that if you follow these steps, the number we get will always 100% of the time be within this range, no matter what this number is. If this number is 2,100,064,012 or whatever the number, if you follow through these steps, we will always end up with a number that is still constrained within these values. So this works well, but there is one small step that's potentially missing here. So let me show another example of going through this down here. So suppose we have this number, 88,073, but now instead of having a minimum and a maximum between 1 and 100, suppose for some reason that we need a minimum of 250 and a maximum of 500. I don't know why you would need that, but let's just say that's the need. So again, we calculate our range. We take our maximum minus our minimum and add 1. So 500 minus 250 plus 1 is 251. And then we calculate the quotient again by taking the original random number, dividing it by the range, and keeping the whole number. So when you do this division, of course, we're going to end up with a bunch of decimal points, but we don't worry about those. We're only interested in the whole number. And then to calculate the product, again, take the quotient times the range, and you end up with the product. Then to calculate the remainder, you just take the original random number, subtract off that number that we just calculated, and that gives you the remainder value. But you'll see a problem here. 223 is not within this range. But the way that we can make it within the range is very simple. We then do a final value calculation where we take the remainder, which was this value here, and we just simply add the min rand onto it. So when we take the number that we calculated, add on the minimum value, that then brings us up to 473, which puts us within this range. Because essentially, when our range does not start at, or when our min rand does not start at 0, we're going to have some kind of offset value that we need to add in. And that's all this is doing. And again, you'll find that if you follow through these steps, no matter what your number is up here, your number down here will always be within this range if you follow these steps. Okay, so there isn't a single assembly, an ARM assembly instruction that I'm aware of where I can just put in this value and these values and get this out. So we're going to have to write some code to go through these steps here, but it's really simple. So let's take a look at that. Let's take a look at how this would look in code. So the first assumption we're going to make so that we can follow along with our registers here is we're going to assume that R1 holds the random number. We're going to assume that R3 holds the minimum rand, and we're going to assume that R5 holds the range. For the sake of what we're doing here, we don't actually need the max rand. Once we've calculated the range, we're done with max rand. So the way we can do this in ARM assembly is we can say udiv R6 is equal to R1 divided by R5. And that step there is equal to saying quotient is equal to rand divided by range, which is what we did here. And then next we want to say R7 is equal to R6 times R5, which is the same thing as saying product is equal to quotient times range, which again is the same thing we did right here. And then we want to subtract. We want to say R1 is equal to R1 minus R7, which is the same thing as saying that the remainder, which will go into R1, is equal to the original random number minus the product that we just calculated right here, and that will give us the remainder. But then we could potentially have that offset that we talked about. So we want to say our final number, or our final value, is going to be equal to the remainder that we just calculated here, so R1, plus the minimum rand. So this just says R1 is equal to R1 plus R3. You can do it like that also, but if you leave out that second R1, it's the same thing, but I'll go ahead and add it in there for clarity. So here we're saying R1 is equal to R1 plus R3. And that's the code that's required in order to make sure that our random number that we give back to the calling function is guaranteed to always be within the range that was specified in R0 and R1. All right, so I'm going to say that's going to wrap it up for this video. When we come back in part 3, we'll go ahead and implement the code to make this happen, and then we'll start going through and doing some testing to make sure that everything is working correctly. If you made it all the way to the end of the video, thank you so much for watching, and I really hope you make it back in the next part.